Welcome to our presentation. Some of us learn from our own mistakes and experiences, and some of us are wise enough to learn from the experiences and mistakes of others. Today, we share case studies. We will pull back the curtain, perhaps share a little dirty laundry, and tell you through our anatomy of lessons learned. If I only knew then. This is being presented by SCO's own Bob Talley, Samantha Farrington, Jeff Schmadeke, and Ralph Taylor.
Assume this works.
Yeah,
Forward and back. Forward. Good.
I didn't say that.
We're going to let you hold your questions to the end. Can lights have been used in both acoustic tile ceilings and sheetrock ceilings for a long time. My house still has lights like this one, which is interesting because that's not where it is on my slide, but that's all right. I removed the lamps from this one so that you could see that socket behind it. All electrical serving it can be inspected during rough-in, and once the sheetrock is installed, it can be fully maintained through the aperture. People like the looks of can lights. Whoa. There's interesting things going on with this. Yeah, I'm not sure which one you've got here. Okay. Well, did they load the right one? You didn't load it.
Yeah.
Okay, they moved. Did you swap it?
Just, yeah.
All right, we'll keep going. So we're gonna fly because this is not the presentation I was supposed to have up here. They've changed it. This is the presentation the way it was 2 weeks ago. So, right?
Yeah.
Yeah. We'll check it afterwards. So I'm just gonna keep going and tell you what's going on. This is bringing up a picture of a UL fixture. This is a fluorescent fixture. We don't use fluorescents that much anymore. Everybody's going to LED. But I'm going to show you the fluorescent so that you'll know why things are going wrong with LEDs now. You may have heard there's some problems with our LED fixtures. So incandescents are one kind of fixture. You can see everything. The fluorescent, you can see the lamp. If it's above the ceiling, you'd see the lamp. You see that box? That box is right adjacent to the edge of the aperture. You could pull down that reflector. Usually there's a panel in there you can open up, and you can, if it's a big enough fixture, I originally saw it in 9-inch cans, but you could access the backside of that junction box where the building's permanent wiring is. And then the driver is attached to that box. LEDs are not built the same way. LEDs have a box. The permanent wiring terminates in that box, but then they have a driver. And some of them have a driver that's on the end of a cord. Sometimes they have that driver laying above the ceiling somewhere. It's just not built the same way. And the LEDs got smaller. So all kinds of interesting things start happening when you do that. I'm going to talk about fluorescents and incandescents and LEDs because they have changed. And we thought, well, UL should have something to say about this, and they kind of did. They don't really want to say much about it. Go to the next one. In 2015, I showed this picture at the State Construction Conference, and I made a comment about it. That you're going to have that box is right up there above the circle that I'm showing. And that little white box that you can see for this particular fluorescent fixture is an interesting thing because this is going to be a hard ceiling. And that white box that they've added is a mud ring that's going to get in the sheetrock. Tell me how you're going to put your hand through that aperture to try and service that fixture at the end of construction. That's not going to happen. So was this thing ever UL listed for this hard ceiling? And you're going to find out something. UL ratings are for the safety of the fixture. It doesn't say whether it's in a hard ceiling or not. You as the designer and Mr. Contractor and Mr. Inspector are all going to make sure that it is accessible when it's done. I don't think most of us knew that that was how that worked. So, is that box above it accessible? Since you can't go through the mud ring without moving part of the ceiling, it means you're going to have some way to get above the ceiling. You're going to add a 2x2 access door next to every one of these nice little fixtures that had this only a 1x2 inch opening in it. What is your plan? The reason I'm telling you about this is that I got called over after an event in one of our buildings. We had some kind of an electrical surge, and in that surge, 680 LED fixtures went out. 80 of those fixtures are in hard ceilings like this. Now, the rest of them, the 600, we could pop the tile out of, just like in this room, you could pop the tile out of the way, get up top, service the LED fixture, but not these. So our electrical shop, which may be sitting in this room, called me over, stared me down and said, "What did you do? You let them put a fixture in here that I can't change the driver on." And I looked at it carefully and thought, well, I'm not quite sure. So I went up above the ceiling, and there you can see the picture I took. 5 inches away from that 6-inch aperture, there is a box. Now, I cannot put my 2 hands through a 6-inch opening and keep my eyes on that box. It's not safe to ask an electrician to stick their hands above that ceiling and to open up a 277-volt box that you can only put one hand on at a time. That's just not safe. So now I'm really confused. I have a fixture that we approved somehow, an engineer specified it. Our inspections went over there, and I kept saying to everybody, make sure, because of our 2015, make sure that we've got fixtures that can be serviced. And everybody assured me they could. Do you know why you can assure everyone that it's serviceable? When do we approve light fixture installation? At rough end. Is there a ceiling up there when we're approving these fixtures? No. And I went to a couple of sites, and you know what I saw the folks do? They stuck their heads up through the framing and looked at the fixtures and said, "Oh yeah, it looks good." Well, once the ceiling's there, the fixture's already approved. Nobody's thinking about it. So this starts failing at multiple points. And once you kind of realize, okay, we've done this for a long time. Oh, we were doing it with fluorescents. We assumed it was like a fluorescent, except now it's an LED. It has different parts, and for some reason, they moved the box. The box isn't at the edge. I don't know why I think most we have found are at least 3 inches to 5 inches away from the aperture. That's problematic. So I went to UL and I asked the guy, Jeff Fecto is who I specifically went and asked, and said, please explain to me how we got this fixture that has a UL listing. And Jeff's comment was, well, there's a tag on it. What does it say? And it says, it's for suspended ceilings. Is that hard ceiling a suspended ceiling? Well, I asked the contractor that. Is that a suspended ceiling? The contractor said, well, of course it's a suspended ceiling. Otherwise, it'd be a floor. Right? So it's not a suspended ceiling. A suspended ceiling is like what you have in this room with tiles that drop in and the tiles are suspended. So we've got some problems with definitions, which is probably why UL doesn't want to talk about it either. So UL has now told us we've got some options coming. They tell me that there's eventually going to be a listing that will address this and say that it is listed for service through the aperture. So we have 80 fixtures we needed to replace. You can go to the UL standard 1598 on luminaires. I'd encourage you to read it. It was most recently modified in 2024. January 2024, I believe. That's going to get interesting in a second here. Yeah, so UL 2024, it's when you go onto the UL website and you ask for permission to go into the data and read it, it keeps wanting you to buy it. But if you read carefully, you can see that you can see the digital edition. So keep looking across the page and say, I want to read the digital edition. It will let you read the standard without having to buy it. You can save thousands of dollars doing it that way. What we all have to do. The NEC is also going to address this luminary issue. The UL is going to tell you how it's built for construction, for mechanical, for those kinds of issues. As far as I know right now, it still doesn't address the aperture issue. The NEC requires some specific things about the fixture. Any box that is installed, we need 3 inches of wire to come out of the box. Right? 3 inches of wire. If you've ever been through an electrical inspection, my inspectors, if they're in here, would say they want at least 3 inches of wire out of the box into the room so that you can work with it. That's it, 300.14 of the National Electrical Code. Okay, if that box is 5 inches away from the edge, I'm not getting 3 inches of wire out the hole into the room. It's got to not only come out of that box, but then it's got to come down into the room. You're not going to shove that much wire back into that box. Those boxes aren't that big. So that's why you've got to get that hole in that aperture. If you're going to surface it through the aperture, you got to get that thing bigger. Or you got to have a catwalk above it, a door next to each one of them. One of the things I've seen, NC State's got some over in the classrooms, they'll have a section of tile ceiling with hard ceiling adjacent. And it creates an interesting pattern across the room, but you're servicing the stuff that's in the hard ceiling from the accessible tile that's right adjacent. And so there'll be these funky little patterns all over the ceiling. Partly, I think, now that I'm looking back at it to figure out, they knew you needed access to get to those LED type fixtures. All right, so NEC, you're gonna have access because you're gonna have some way that we're gonna have to all start thinking about how to get access to it. OSHA wants safe access for our electricians. It's not fair for us to put something up that they have to stick their hands in. I'll admit they got an electrician out there for me to go look at it one day, and they said, oh, Bob, we figured out he can actually put his hands in that 6-inch hole. I said, really? And I admit the guy's about this tall, and he got up on a ladder and he shoved his hands, both hands, into that thing, and he was going to do it on the box. And I got my camera out and I took pictures like, doggone it, he really is doing it. And then I got on the ladder. He couldn't see it. He had learned where all the wires were. He kept sticking his head up there, but he was doing it without being able to see it. Okay, you may prove that you can get your hands on it, but you're not going to prove you can see it at the same time. So if you try and do this, you're going to get busted on a project. The other thing I can tell you about it is that driver, and I've had several people try and do some interesting things with the drivers. Ballasts were fluorescent, drivers are LED. The manufacturers are doing some interesting things. They're putting the drivers on plugs. They said, oh, we can do it if we put a plug on the driver. Well, you still got 277 volt up there, and you still can't put your eyes on the end of the permanent wiring. You can play all kinds of games with it, but if you specify something that you're not getting to every bit of that fixture, you're at a pretty big risk. I just need to warn you about it. And they tell me there's a new standard coming. We went out and looked, and we did find a fixture that we could agree that you could service through the aperture. The lens drops out and you service it. Any idea how big an aperture you have to get your hands in there and service it? 14 inches. So if you want a can light that we know that works, and it was pricey. What did we pay? $1,500 a piece, I think, for them. So what it allowed us to do was we compared. Do I put in a 2x2 door next to every fixture, and I have 80 of them? Or it turns out these big 14-inch fixtures produce way more light. So we're taking out 12 fixtures and replacing with 4. And I don't have to put any doors. It actually ends up working, and it looks like this. And this is a mock-up before we took out all of the 4-inch cans, or the 6-inch cans. You see the big 14 inchers. They look pretty good. And when you go look at the final product without any of the 6-inch cans in there, it looks really nice. So there is a way to do it. I'll admit that none of us knew this. And I'll tell you how, we're trying to tell you what we don't know either, and we expect you didn't know it. I called Matt Morbois. Matt is a very good electrical engineer. When we first found this problem, I said, Matt, we got a problem with these cans. Our warning's not good enough. He said, oh, I know, we got a warning. I said, our warning's not good enough. It's not addressing what's happening. He said, oh no, Bob, we got you covered. And I got him over there to come look at it. And he said, oh my God, we don't have you covered. We're not warning folks it can't be done. And I'm warning you, I don't think it can be done until we get in hard ceilings, until we get fixtures that actually have a UL tag for going through the aperture. UL did never address that. There's something they didn't really want to talk about. Manufacturers want to sell product. I do believe that's true. If I know that I'm only going to buy 4 instead of 12, why would they want to change? It's not ultimately, it's not going to be a lot of difference in price in a 14-inch and a 6-inch, but they will sell a lot less fixtures for any job site if you're going to a 14-incher. So I think just the cost of installing it and what it does for manufacturers has been part of the problem here. And they want to sell product, and a lot of product. So that's why the fixtures kept getting smaller and smaller. You have to keep putting more and more in. Now, I'm going to tell you about something. I'm going to talk about plumbing. I don't normally talk about plumbing. I tell my staff on a regular basis, I'm not civil, I'm electrical. I'm not plumbing, I'm electrical. I don't do any of that other stuff, I'm electrical. But I do look after the group. And back in 2015, here's another thing from 2015, I got a video. This is one picture. I'm going to give you a warning that says you can shut your eyes before I actually play the video. So I'm going to tell you a story first. In 2015, DOA was experiencing a rash of clogs in our downtown sewer lines. I even received a video from our plumbing shop. They were disgusted. We asked why. What's going on? How is this possible? All this water damage, why now? Well, it turns out in 2007, we did an ESCO project and we installed low flow water saving fixtures all over the place. In our old buildings, we installed low flow fixtures. Maybe you've already know the same thing I do now, and that is that we had old cast iron pipe. And our old cast iron pipe has got very rough interiors, and it is designed for full flow. So when you go to low flow fixtures designed for full flow, that solids start to stay in the pipe. And in that old cast iron, that paper that's in there starts forming like a paper mache rock. And every weekend it gets to dry a little more and add another couple of layers of paper until it forms something akin to a rock inside of your plumbing. I called friends of mine in Kansas City and in St. Louis who are engineers, and I said, y'all having these kinds of problems? And they said, you didn't put low flow on old cast iron piping. And I said, well, I didn't do it, but somebody did. And they said, don't never do that. Well, here's my story, and I'll warn you before I play the video. 2022, after the pandemic, everybody started putting in low flow touchless fixtures. All touchless fixtures are low flow. And I don't think we've changed out our cast iron pipe anywhere in this state. So what's going to happen? You may have what happened to us that resulted in a video. The plumbing department said they were called to a clog on the 5th floor of a building. They got up there with their jetting and they started to jet the line. And they heard the clog finally break free and start to move. And they could hear this rock move through the lines as they continued to jet massive amounts of water to move that thing. it hit the vertical riser and they could hear it scraping the sides and breaking more stuff free as it moved. Apparently there were more clogs on the lower level of this building because when that clog hit the basement of our building, a pressure wave was created, and that pressure wave made the downstairs toilets throw up. Yeah. You can laugh because you're not the plumber that went in and he started to clean up and then thought, oh, I need to take a video of this. And here's the video. So close your eyes if you've got a weak stomach or are still thinking about lunch. Here it is. Doesn't last long.
Basement. Agricultural annex.
And this is the hallway outside. It did the whole basement. Yeah. So my word to you is if you have old cast iron pipe in your building and you put in those touchless fixtures, you need to think long and hard about putting in well, it went past it. If you have touchless fixtures, you need a jetting program for preventative maintenance before you have this problem. I think, Ralph, you want to reload?
Yeah. Yeah.
We don't have the right presentation. And it will really mess with them.
You are screen sharing. Let's see.
Just fire it straight off of your drive.
Yeah.
Just right into her slide.
To cancel it. Okay. And then. That's right. Okay.
Right there.
And then I can't get to the. Sorry about that. And from.
How many of y'all have installed those low flow fixtures? Any idea? Yeah. Have you considered the cast iron? Maybe you will now. I know Will Johnson told me that after he saw that video, he said, I will never use a basement toilet again. Just in case.
Thanks, Bob.
There you go.
I wish we knew that historic brick buildings were built different, whether that's due to older construction methods, different functionality of materials used back then, or even just due to previous renovations, like the North Carolina Department of Labor building. This is a North Carolina registered historic building. It was built in 1888 and has undergone multiple renovations over the years. This building used to only be 2 stories. Well, how does that happen? Some of you may think that it was a 2-story building that they then built 2 more stories directly on top of. But if you actually look at the exterior design features of this building, go ahead, look, check it out. You may start to notice that the design features are actually pretty consistent from ground level to the roof. You may notice that the bricks between the windows are a little bit darker than the rest of the brick. They renovated this building to go from 2 20-foot stories to 4 10-foot stories. Each of those window openings used to be the full height of the original stories. Keep this in mind as we go through this presentation. The North Carolina Labor Building is currently undergoing a replacement project to replace the existing windows. We won't be getting into too many specifics about this project, but we will be using it as a general example for a topic of historic brick buildings are built different. The base design for the replacement of the windows had a general idea of remove the old, preserve what could be preserved, and install the new. Once the project was underway, the GC removed a sample window to help expose some of the hidden conditions. And as more existing windows began to be removed, we really began to understand that historic brick buildings are built different. We realized that the hidden conditions not only varied from the assumptions in the base design, but they also varied from window to window. A handful of these conditions are due to the renovation from 2 to 4 stories, but not all of them. The lintel only supports the first width of exterior bricks, rather than as assumed to be across the top of the window as well. Header bricks either sit directly on top of the existing window, or they're arched over the window. Non-waterproof elements in the window or in the wall was completely deteriorated beyond repair or reuse. So what this means is that the framing materials that were used to support the windows are no longer actually supporting the window. These windows are basically held in place by caulk. Interior sills are left as void spaces as these materials were removed. In some locations, though, the sills are completely solid brick and are actually perfectly fine. Jambs are also left as void spaces until you get back to the broken brick pieces that are held together by brittle mortar. This combination of broken brick and brittle mortar led to not having anything solid to attach to new windows to. The depth of these void spaces differed from window to window because the bricks were actually installed around the windows rather than as we install them today with a set framed opening after the wall is already built. A handful of solutions have been utilized on this project to work around these challenges, but as you all know, with additional solutions come additional cost. New pressure-treated 2x lumber with metal brackets were installed to help fill these jam spaces and to also give a solid structural member to attach the new windows to. Then additional liquid flashing was then applied to the 2x, and light gauge sheet metal has been installed to help support those header bricks. The several findings of the North Carolina Labor Building led us to believe that if one historic brick building was built different than expected, then the other buildings in our downtown area probably are as well. And from there, the other historic brick buildings across our state are also likely built different. These historic brick buildings were built between the mid-1800s to early 1900s. Several specific design features and methods that were used back then differ from how we build brick buildings today. Through water intrusion investigations at some of our other downtown historic brick buildings, through reading online articles by the Wisconsin Historical Society, ICRI Concrete Repairs, and Assyri Designs, and through walking around our downtown government complex, actually investigating the exterior features of our other existing historical brick buildings. Through all of this, we began to understand these older designs and methods. The general construction of the exterior walls was designed to allow the water to flow away from the openings, and also to allow the moisture to be absorbed by the exterior brick and mortar. The openings are set back further to prevent water from flowing into the headers and down the jambs. Steep slope sills that are made of waterproof or water-resistant materials help to prevent water from flowing under the openings. And there are no weep holes or through-wall flashing in these buildings. The materials that were used for the brick and mortar, again, were meant to allow the moisture to be absorbed and then also evaporated before it even got into the building. The mortar was also meant to be flexible, to allow the building to expand and contract, to breathe. So as you are completing the design phase for any exterior renovation or replacement projects on any North Carolina historic brick building, please remember that historic brick buildings are built different. Keep these items under consideration. Assume that the materials in the exterior walls are deteriorated beyond repair or reuse. How are you going to preserve the original design intentions of the exterior wall construction? How are you going to maintain the functionality of the existing materials and continue that for any new materials? You cannot prevent the exterior bricks or mortars from allowing the moisture to be absorbed and then evaporated. Do not seal these walls. Review the history of the building. Has it undergone any major renovations over the years? Was it previously painted? Has there been any long-term exposure to heat or water? All of these and more are important to keep under consideration during the design phase to try to prevent as many change orders during construction as possible but also to actually make sure that we are preserving our historic brick buildings as they deserve. So if you remember anything from today, remember that historic brick buildings are built different.
All right. The definition of sustain is to keep in existence, to maintain, continue, or prolong. I'm gonna do a short case study on a sustainability project that unfortunately did not live up to that definition. This is a rainwater harvesting system. It was one of the building's sustainability features, and it was designed to collect rainwater and store it in a large underground cistern where it can be used later for irrigation, toilet flushing, and cooling tower makeup. At first glance, this system checks a lot of boxes. It reduces potable water use. It's got multiple stages of filtration, UV treatment, and is almost completely automated. However, as we'll see in a minute, it had some design and operational issues that made its long-term sustainability difficult. So here you can see the two equipment skids that make up the rainwater harvesting system. On the left is the irrigation system, and on the right, the non-potable building use system, which supplies the water for the toilets and cooling towers. These two subsystems are almost identical. The main differences are their flow rates and this green 500-gallon buffer tank, which is used to store the treated water for the building use. So let's take a closer look at some of the individual components and where we ran into some problems. All right, the controls were problematic early on in the project. As a matter of fact, the rainwater system was never fully commissioned because there were still too many bugs to be worked out in the controls at that time. The company that configured and installed the rainwater harvesting didn't use the building automation system. Instead, they went with a custom programmed PLC. So unfortunately, we couldn't utilize the existing training or service contracts that our facility management had with some of the bigger name controls companies. And to make matters worse, that company went out of business some years later, so we lost access to their tech support as well. This blue thing is called a centrifugal separator. It's the first in the series of filters and is designed to remove the larger or heavier debris from the rainwater. These devices work by creating a vortex in the water and use centrifugal force to separate out the heavier solids from the liquid. Now, the velocity of water flowing through each of these chambers is very important in this process. So each separator is rated for a specific flow range. Ours were rated for 65 to 108 gallons per minute. However, the problem is our pumps don't deliver enough flow to meet that requirement, especially the irrigation pump at just 25 GPM. As a result, our separators likely weren't operating at peak efficiency, and we're probably passing some debris downstream to the next stage of filters. That brings us to the sediment filters. So these large yellow tanks here are filled with either sand or carbon media. And these are a self-cleaning type of filter, also known as a backwashing filter. So in order to stay effective, they need to go through a periodic backwashing cycle where the flow of water, the valve on top reverses the flow of water and the media is flushed from the bottom up. Now, the larger the cylinder, the more media is in the tank and the more backwash flow is needed to flush it. And just as before, our filters are oversized for our pumps and we're not delivering enough flow to meet the backwashing requirements. That can cause a number of issues. So for one, if the media isn't completely flushed, we're going to see an increased pressure drop across the filter. And that could affect pump performance, especially if the pump may be lacking in head capacity to begin with. Second, over time, the media can develop channels or pathways where the rainwater takes the path of least resistance, reducing the effectiveness of the filter. And then lastly, the media can become compacted, again, reducing its effectiveness and shortening the service life of the filter. And then there's the question of what to do with the dirty backwash water. The original plan was to discharge the floor drain, but it was discovered during construction that the floor drains wouldn't handle the flow. The solution was then to reroute the backwash outside of the building, but that led to flooding of the adjacent planters and patio area behind the building. And worse yet, a lot of that dirty backwash water eventually made its way back into the underground cistern, which is also located in this area. Eventually, our facilities staff had to come up with a workaround. So when a backwashing cycle was required, they would shut down the rainwater system and utilize the treated water buffer tank to capture the dirty backwash. They would then connect a long hose and run it out to a nearby storm sewer. But remember, this tank here was intended to store the clean treated water. So of course they would have to clean out the inside of the tank before returning it to normal service. So as you can imagine, this was both an inefficient and labor-intensive process and ultimately led to the system being abandoned. So this system failed not because rainwater harvesting was a bad idea, but because it became a burden to maintain and operate. So remember, we can't achieve sustainability if the system itself is unsustainable. Thank you.
What could be easier than a like-for-like replacement? Easy as 1, 2, 3. No brainer. We could do this blindfolded, right? So here's our story about a like-for-like generator replacement. The situation, we had requested funding for several years to replace or upgrade the generator, and those requests went unfunded. We had a 600 kW diesel generator. We had a 26-year-old equipment at the time. It was located off the loading dock, and the loading dock and the generator room were below grade. So during routine generator testing, the remote radiator failed, the coolant flowed over the floor, the generator engine overheated, and the generator shut down on overtemp condition. Well, the generator was required for building occupancy. It ran egress lighting and it ran the fire pump. So we immediately took action to get a rental generator in place that sat outside the building with the cords running down through the exhaust areaway, so we could continue to operate the building. But what were we going to do to get the generator up and operating? Were we going to repair or replace? So the radiator was shot, as I said. Even if we replaced the radiator, we had a 26-year-old generator. We don't know how much damage it had sustained. We didn't know how much service life was left. We didn't even know if it would run. So we decided that we would do a replacement. So here we had an emergency project with a priority objective of getting this generator replaced and back up and operating as soon as possible. We could have done a full-blown design, but it's a like-for-like replacement. No fancy design needed. We just needed to get a generator the same size back in the same place and operating again. What could be easier?
Yeah.
Or as Bob would say, what could go wrong? So the original design had really been done 26 years earlier with the building, right? The design must have been accurate. Nothing would have changed in the last 26 years, right? Well, we did know that no additional load had been added to the generator, so we were pretty confident about the size of the generator. So what we were looking at was really more of a remove and replace. Piece of cake, right? Okay. But what did we miss? Is it possible that we missed something important? Okay, well, we knew that we had the 600 kW generator. We knew we had a belly tank, a fuel tank. We were doing in-house design. Oh, but really no design was required. So we picked a GC who had an unlimited electrical license, and they got the generator manufacturer involved. They came out, they looked, they did an assessment. They gave us a quote basically for a like-for-like generator replacement. So we were good to go. They did make some recommendations. For instance, they said, don't go back with a remote radiator. With the radiator attached, you'll have to duct that radiator airflow to the exhaust. Fairly minor changes. We had a lead time of about 26 to 28 weeks, but we got the equipment ordered and we waited. Okay. We'll talk a little bit about the ventilation requirement. Oh, yes. So as you see on the first picture, that generator was not going to fit through that door. The block wall had a louver, a grill, no larger than 3 feet by 3 feet. Our mechanical engineer did a back of the envelope calculation and said that will not provide for enough airflow for combustion and cooling that generator. So we looked at a different solution. We'd have to go with a bigger grill, or actually a better solution, turn a block wall that was coming out anyway into a full louvered wall. This shows the fan for ventilation of the room. And that was really the first find was the ventilation. Good catch. Could there be something else? Okay. Months later, the generator arrived. The generator sat out on the street as the riggers came in to remove the existing generator. That is when they decided to measure the pad, the concrete. Yes, yes. So same size generator. Oh, as far as capacity, physically, the new generator was larger and would not fit on the existing pad. The contractor had to pour a larger pad, wait for it to strengthen, and then place the generator in there. Okay, pad, find number 2. Okay. When the new generator was installed, we did a NFPA 110 generator test, including a full load bank test. And I mentioned earlier that the loading dock and the generator room were below grade, basically the basement of the building. So the rental generator sitting basically on the sidewalk outside, and from the room, the exhaust left the room above the generator, went out into an areaway, but the exhaust vent turned down into a pit, into that areaway, and the exhaust then would rise up through the metal grate, as you see there, and it would cool in that process, to a certain extent. So we ran that generator test, and it's set up with 3 parts. Start at 30% load for about 30 minutes. It goes to 50% or higher for 30 minutes, and you could hear the generator kick in with the higher load. And then the plan is to go to 100% rated load for a full hour. So when it kicked in to 100%, there was an audible change. You could hear it, you could feel it. It was running hard. So we missed the exhaust temperature. There's the load bank. If we had read every line of the 64-page cut sheet, it was clearly stated that the exhaust temperature was 998 degrees Fahrenheit, almost 1,000 degrees, much higher than the existing generator. So you can see the manifold after running first time at 100%, the discoloration. When that exhaust came up above that metal grate, there were trees around. There was some landscaping in those trees. The leaves on the trees went from green to brown to crispy. We halted the test. We also melted the cables that were running through the same areaway. That's a story for another day. So we had missed the exhaust temperature. Although the exhaust was not in the walkway, the proximity and the high temperatures gave us concern for a safety risk. So under the same emergency project, we reached out to a mechanical contractor to help us with a generator exhaust modification. We went with a double wall insulated exhaust vent. So same pathway leaving the building. Instead of turning down, it turned up. It went through that grate and extended above. And you can see here, some people call it the snorkel. And we did have some protection around it to keep folks from getting up and reaching it. The small sign says generator exhaust. Okay. So going back through, what did we miss? We talked about ventilation requirements, the pad, the exhaust temperature. Do you remember when I said this was at the loading dock? The picture is looking out the loading dock. So during normal hours with that loading dock door up, plenty of airflow. You know, power outages don't usually get scheduled, and they don't always happen during normal hours when the loading dock door is up. And that loading dock door was a solid door. When it's down, it significantly reduces the amount of airflow. So if you look at this pretty closely, you can see this with the door up. We replaced it. I don't have the picture of the existing door, but you will see the loading dock door closed provides the physical security, but some people wouldn't even see the difference. This is with the door closed, plenty of airflow. Okay. So this is just a recap. We missed a few things, including the pad. There is a good picture of the full wall louver looking out through the previously block wall that was replaced. All in all, in the end, this was really a pretty successful project, generator replacement project, and also generator room ventilation improvement project. Oh, and a generator exhaust upgrade project, and a loading dock door replacement project. Not all that we had thought about at the very beginning. I can only hope that if we had approached this as a traditional design project, that the designer would have taken a look at the entire project and identified some of those things that we stumbled into. So perhaps the emergency nature of this project is how and maybe why we missed some of those things. So what did I learn from this project? Even with like-for-like equipment replacement projects, the equipment will not be exactly the same. So we're going to do a recap of what we've learned from all of our lessons learned. We saw some problematic installations of LED recessed can fixtures, low flow plumbing fixtures. We learned that historic brick buildings are built different. We've been told that sustainability needs to be sustainable. And even like for like equipment replacements, the equipment will not be exactly the same. So unfortunately, we've used up most of or all of our time. If you want to catch us, we don't want to hold folks from break, but if you want to catch us, we can answer some questions, but we also want to release folks to go to break as needed. So thank you.